Hi guys. In the last video, we saw how we can plot 2D and 3D vectors in Matlab. Now we will see how we can visualize the plane which contains these two vectors in Matlab. So I have two vectors, I cap plus 2j cap plus 3k cap and 4i plus 5j plus 6k here. So first we need to find the equation of the plane which contains these two vectors. To find the equation of a plane given two vectors, we find the cross product to find the normal vector to the plane and then use the dot product to find the constant term in the equation to formulate the equation. We'll see that how we form the equation. So before that, let's look into that in steps. So first, let's define the two vectors and store them in a workspace. So we have our V1, 1, 2, 3, and V2, 4, 5, and 6. So note that these are independent vectors. So keep that in mind. So V1 and V2, they are the two independent vectors that we are given. Now, the next step is to find a vector which is perpendicular to both V1 and V2. So, perpendicular to V1 and V2 means that the vector is perpendicular to the plane which contains both these vectors. So, the cross product of these two vectors gives us the normal vector. So, the second step is to find the normal vector. And to find the normal vector, we have the cross function in Matlab, which evaluates the cross product between two vectors. So when I run this, I get the cross product of V1 and V2, which is 3i minus 3i cap plus 6j cap minus 3k cap, which is nothing but the vector which is normal to the plane that we are going to construct. And the third step is to choose any point on the plane. So it can be the origin or any other given vectors as the position vector of the point. So here I am choosing the origin. Now, you guys might already know how the equation of a plane looks like. So ax plus by plus cz plus d is equal to 0. So this is the equation of the plane, general equation of a plane, and a, b, c, the coefficients of x, y, and z are the terms of the normal vector, and the d is the constant term here. So to find d, we need to find the negative of the dot product of this n and p. So the next step is to find the constant term. Now, since d is since n p is 0, p is the origin, the dot product of n and p will be obviously 0, like I said. So now uh, the next step is to formulate the equation using the normal vector we have found, the normal vector, and the constant term that we have found. So the equation of the plane is the first term of so before that, let me uh, declare x, y, and uh, z as symbolic variables in MATLAB. So the equation of the plane will be n times n of the first term of n times x plus the second term of n times y plus the third term of n times z plus d. So this will be the equation of the plane. So Let's run this to see. So yeah, this is the equation of the plane 6y minus 3x minus 3z. Now we need to plot this plane in Matlab on a figure. So let's proceed to plot this plane in Matlab. The first step is to use the mesh grid function to generate data points for x and y coordinates of the plane. So let's do that. So x, y is equal to mesh grid minus. So these will be our data points. 5. So let's run this. So this and these are our data points for x and y. And now let's evaluate the corresponding values of z for this x and y values for so for that let's rewrite the equation of the plane, this equation over here, um, in terms of set. So first, that is, I want my variable is set to come in the LHS and all other terms in the right hand side of the equation. So set will be equal to minus of n of 1 times x plus uh, n of 2 times y, um, the whole divided by the coefficient of z, which is nothing but n of 3. So this gives the value for z. Now we can visualize the plane using the surf function or the mesh function in Matlab. So here I am going to use the mesh function. So mesh x comma y comma z will plot the plane. So let's also plot the vectors in the same figure. So that will be called on. Then we have our tree function which plots vectors. So v1 of 1, v2, v1 of 2, comma v3 of 3, and then let's color it red, and let's increase the width of the line too so that we can see it properly. And let's so now let's plot write the command to plot the other vector too, which is the v2 vector. So now then let's add label these vectors so we can identify which vector is what. So v of 1, so let me look whether this will, so yeah, v1 of 1, v1 of 2, uh, v1 of 3, and then the string vector 1, and control plus C, vector 2, and Let's run this block of code. Oh, sorry. So let's run this again. I made a typo here. So yeah, if you open this in the figure window, you can see that I think I made some mistake while plotting vector 1. This should have been v1 of 1. So let's run this again. Yeah. So yes. So this is right this time. So this is you can see both vectors are in the same plane. So this is vector 1 and this is vector 2. So now we can plot the axis if we want here, but I am not doing that. I had already explained how we can plot axis in 3D plots in the last video. So now this is the plane and these are the vectors. So we can also use the surf function to visualize this. So let me use surf function to show you guys how this looks. So let me change this mesh function over here to surf and run this again. So and let me just change the shading to remove all those black lines. So shading inter. So let me run this again. So here again there are the vectors vector 1 and vector 2 and this is the plane. So this is how we use the mesh and surf functions to plot planes in MATLAB. Hope you guys understood this. In the next video, we will be seeing how we can solve linear equations using MATLAB. Thanks for watching. Bye.